Assalamu alaikum warahmatullahi wabarakatuh. I hope everyone is doing good with the winter vacation and with that they are going good with their studies. So here on in the third lecture of your topic frictions and decimals. So if you remember, uh, we have already gone through the two lectures of the current topic, that is frictions and decimals. I suggest you, if you are watching this lecture directly after skipping the first two lectures, then it won't help you in any way. So it's better to first go through the first two lectures and then come to the lecture number 3, that currently you are watching. Here it is. Lecture number 3, topic is frictions and decimals. And I hope you are aware that right now we are on the first part of the topic, that is frictions. We are dealing with frictions right now. So let me have a review of the previous lecture. In the second lecture, we have gone through mixed frictions. Mixed frictions, you can see here, the green line, green arrow that's coming down, are of the form those numbers that include the combination of whole part and a proper fraction part. Again here, 8, 9 by 11, it is a mixed fraction. And if you remember the previous lecture, we are able to convert the mixed fractions into improper fractions. How? The example is given that the second lecture. You can go to the previous lecture and watch the example how to convert mixed fractions into improper fractions. And not only this, the reverse is also possible, to convert improper fractions back to the mixed fraction. Then the second thing that we have discussed, second concept that we have discussed there in the second lecture was about equivalent fractions. I told you equivalent fractions are those fractions that look different from their numerator and their denominator, but when we try to calculate the value of those fractions, we see the value of those fractions came out to be constant. That is, their value comes out to be same. Example here, you can see the arrow here. It is 2 by 5, 4 by 10, 6 by 15. They all are equivalent fractions. Why? Because whatever the value of 2 by 5 will be, same will be the value for 4 by 10, same will be the value for 6 by 15. And I have also told you there in the second lecture that we can calculate, or we can find the equivalent fractions of the given fraction either by multiplying its numerator and denominator by the same number, or by dividing it with the same number. Dividing, in other words, I call their division. We are doing there by the process of cancellation. Now, the third concept that we have done there in the second lecture was about like and unlike fraction. Remember, this topic is very important, and the third lecture that we are going to start, it will help us there very much. Like and unlike fraction. I told you, like fractions, you can see the arrow here, are those fractions whose denominators are equal. So any two fractions or more than two fractions having same denominator, they are said to be like fractions. And in the same way, when we move to unlike fractions, they are the fractions where you will find different denominators. So like and unlike fractions, it only depends upon the denominators. If the denominator of two or more fractions is same, they are said to be like irrespective of their numerator, and if their denominator is different, they are said to be unlike irrespective of their denominator. So, if you remember in the last lecture, I told you like fraction, whenever the concept of like and unlike fraction you are touching, it doesn't deal with a single fraction. It deals with at least two or more fractions. Because whenever we find the comparison between the two things, whenever we try to see the similarity between the things, we usually don't find it in a single thing. We usually take two things and then compare them. So like and unlike friction also help us to compare the things. Now coming to the today's topic, if you have seen the first lecture, the first topic that we have discussed here was about introduction, second was friction and start, and we have done that subtopic, the same topic, that is friction. Now, if you see the third topic here, third topic is about comparing fractions. It is here visible on your screen, comparing fractions. First of all, we will see what do you mean by comparing fractions. Comparing means to just see the comparison between two or more fractions. If you see here, I have just, I will say, simplified it. Sorry, I have just defined it what do you mean by comparing fractions? It means how to calculate which fraction is greater, smaller or equal. We will see among two or more fractions, which one is greater, which one is smaller, and which two or more fractions are said to be equal. It includes at least two fractions. कम से कम बेटा दो fractions होने चाहिए. Then only we can do the comparison between them. Either they can be like fraction or they can be unlike fraction. Now, what will we do? We will take the example of like fraction and we will see how to compare the like fraction. Then we will take few examples of unlike fraction and we will see how to compare unlike fraction. Remember the previous remark, when we have done like and unlike fractions, I have told you we can add or subtract only and only like fractions. If fractions are unlike, then you need to make them like by either finding their LCM or by doing cross multiplication. By these methods, we can make the denominator of two fractions same, and hence we can make them like fraction. That means whenever it is unlike fraction, you have to add them, but first make them like fraction. Then only you can add them. Now, let me have one more slide here. We are going to the next slide. Now, our topic, comparing quantities. Sorry, comparing fractions I am writing. Comparing fractions. Since in the previous lecture we came to know that fractions can be of two types. Either they can be like or they can be unlike. We will take case first. If like fractions. बेटा अगर हमारे पास like fraction है, suppose I will make a question here. I am writing example. With the help of example, we can understand it better. Which one is greater? Now the question here is which one is greater? I will give you the pair of fraction and you have to take out the one that is greater. But remember the fractions here, they will be like fractions. That means their denominators will be same. Let me write the first part here. I am writing 7/9 and 4/9. So let me take this example first. Let me have a solution of it. Whenever you are having two like fractions, बेटा जब भी आपके पास दो like fractions होंगे, whose denominators will be equal, then what you have to do? You have to focus on their numerators because you won't be able to distinguish them on the basis of their denominators. Why? Because their denominators will be same. Now it's obvious that the difference there will be in the numerator. And among the numerator, a fraction who's having greater numerator, वो fraction जिसका numerator बड़ा हो, among two like fractions, that fraction will be considered greater. उस fraction का value ज़्यादा होगा, जिसका numerator बड़ा होगा, or the fraction who's having smaller numerator, will have less than. So it's clear here simply. It is 7 by 9 and 4 by 9. Now clearly their denominators won't distinguish them. It won't give us the comparison because they, by their denominator, they seem to be same and they are like fraction. Now what about the numerators? I am writing 6. 7 by 9 is having greater numerator than 4 by 9, which implies 7 by 9 will be greater than 4 by 9. Simple, very simple. A fraction whose numerator is greater is considered to be greater, provided they are like. One more example. I will take the second example here. Second example I will take. Let me write 9 by 4 and 27 by 4. Solution I am writing. Now, if you have got the concept, you need not write all these things. Since 7 by 9 is having greater numerator than 4 by 9. So you can directly write 9 by 4. Among the two, which one is greater? Because we are doing here, which one is greater? So clearly their denominators are same. So it will be their numerator that and the fraction with greater numerator will be considered greater. So clearly 27 by 4 will be greater than 9 by 4. Why? Or if you are not comfortable with this, you can write it like this. 9 by 4 is less than 27 by 4. It means same. If you focus on 27 by 4, it's still greater than 9 by 4. And if you focus here on 27, it's still greater than 9. Both ways are correct. You can put the answer, and the two ways you can put the answer in one way. So you can write your answer any way among the two given options. But the problem here is, sir, we got that when the fractions are like, then whosoever is greater in the numerator will be considered greater. But there is an exception there. One important concept I will deal here with. Suppose I am having question, compare the two fractions. I will pose an example that is a bit different than like and like concept. Have two fractions are, I am writing here 2 by 9 and 2 by 11. These are two fractions. Now you can see here, these two fractions, whenever we are dealing with like and unlike fractions, we are dealing with denominator. But these two fractions have a different denominator. It means they are unlike. But one important thing is their numerator is equal. The way above two examples, the denominators were equal. It was easy to calculate based on the numerator which one is greater. And we have come to know that the two like fractions, one who is having greater numerator will be considered as greater. Its value will be more than the one having smaller numerator. But here the condition situation is different. They are unlike. We can call them unlike. But the way we use to compare to unlike fraction, here we will use a bit different method. Why? Only because their numerators are same. Whenever two unlike fractions have same numerator, in the above two example, we kept the denominators. Now I am keeping here the numerators, but still they are unlike. Still be unlike. Now, how will I say which one is greater? So in the above two examples, when you are comparing the numerators, a fraction having greater numerator is greater. But just the opposite happens when the numerator is same and denominator is different. A fraction with smaller denominator. A fraction with smaller denominator is greater than the fraction with greater denominator. When you have to compare two fractions having same numerator but different denominator, then keep in mind that fraction will be greater whose denominator will be smaller. जिसका denominator smaller होगा उस fraction का value ज़्यादा. Now you can have a simple concept. It means simply two breads have been divided among 9 people. Numerator means we are distributing. Denominator means among denominators we are distributing. Two breads distributed among 9 people. Now here same two breads among 11 people. Now which group will get more? So अगर 9 में 2 को डिवाइड करना है फिर उन्हीं 2 को 11 में डिवाइड करना है. Obviously जो 9 होंगे उनका कुछ ज्यादा मिलेगा as compared to those that group which contain 11 people. So that is why this 2 by 9 will be greater than 2 by 11. So it is simply 2 by 9 is greater than 2 by 11. So whenever denominator, on the basis of denominator you have to compare, you will take that fraction greater whose denominator is small. So this is how we will compare the like fractions. Now the second case we are moving to is case second we have if unlike fractions. बेटा अब अगर हमारे पास दो unlike fractions, first I will take the same example, the one that I have taken in the previous case and the last example. I will take one of the example like that. So let me have first example. Compare 5 by 7 and 5 by 15. Or I will change it a bit. I will write 5 by 13, sorry. 13 and 5 by 7. Now it's same as the previous example. When you write its solution, you should be able to now answer by yourself. Now their numerators are same, denominators are different, still they are unlike. But for such unlike fractions whose numerators are equal, we need not to go for the process the way we will do it for the rest of unlike fractions. We can go here for denominators because numerators won't compare them, it is same. Now if you have to take the concept, it means 5 biscuits divided among 13 people. Here 5 biscuits divided among 7 people. Now which group of people will get more? Each one. So obviously बात है अगर 5 बिस्किट साथ में बांटने हैं तो उनको एक से थोड़ा कम मिलेगा और अगर 5 बिस्किट 13 में बांटो उनको भी एक से कम मिलेगा लेकिन बहुत कम मिलेगा. So clearly the fraction whose denominator is greater is actually the one that is smaller. So here when you have to compare it is 5 by 13 is smaller than 5 by 7. I hope you got this. Now the second example, because we are dealing with unlike fractions. Now let me take the case. Second example I am considering. When both numerator and denominator, suppose I am having a fraction 5 by 7 and 12 by 13. 5 by 7 and 12 by, let me write in place of 13. I will take one more example, different I will take. 12 by, sorry, 70. Now here the situation is different. 5 by 7 and 12 by 7. Neither the numerator is same nor the denominator is same. Now this is the perfect example of comparing the unlike fraction. In such a case, when neither numerator is same nor denominator is same, what you are supposed to do? You have first thing you have to do is to make their denominators same. You have to make their denominators same. So the best and the general way of making denominators equal is to take the LCM of denominators. Whatever the LCM of denominators will come out to be, we will try to make same LCM as the denominator of first fraction and same LCM as the denominator of second fraction. So first thing I will write here, solution I am writing. 6 both fractions are alike. Therefore, LCM of 7 and 70. Now, how to find LCM? They both are prime, we can multiply them and we will get their LCM. But the way of how to find the LCM, you may have done that in the lower class. If you haven't done, see how to do the LCM. So what you have to do, you have to make up a scale. Write both numbers 7 and 17 at the top. Now, you have to see among the two numbers, either one or both, are they coming in any table starting from 2? In LCM process, we usually take prime factors. That means our numbers should be in the product of prime numbers. Now we will see 7 and 17. Neither they are coming in the table of 2, nor they are coming in the table of 3, nor they are coming in the table of 5. So why you have to put 4? Because 4 is not a prime number. To find LCM of two numbers, we usually by prime factorization method, what we are supposed to do? We are trying to split them into the product of prime numbers. So neither they are coming in the table of 5 nor 7. Sorry, 7 may author. 7 comes in the table of 7, so I am just writing 7 1 or 7. And 17 isn't coming in the table of 7, write it back. Now, put the line, again a line, now we are having 1 and 17. Up to 7 we have reached 8, 9, 10, we will not take 11. But 11 के table में 17 आता नहीं. 12. We need not to check 13, no, 14, 15, 16. Directly we will write 17. 1 will be as it is and 1s are 17. Now LCM of 7 and 17 will be the product of these prime numbers. That is 7 into 17. What is that? 7, 7 are, you have to multiple 7 with the first 7, 1 is place digit. Usually most of us, they use to multiple 7 with 1, but that's wrong. You have to multiple 7 with 7. 7, 7 are 49, 9, 4 will get carried to the next place. 10th place, 7, 1 or 7 plus 4 is 11. So 119 is the LCM of 7 and 17. Now I came to know the LCM of 7 and 17. Now what you have to do, you have to make its denominator 119, its denominator 119. How? I am writing now therefore 5 by 7 first we are taking. Now you need to multiple. How will you make the denominator 119? By multiplying 7 with any number. See, not any number, the number by which we will get 190. Now I already know 7 1 are 7, 7 10s are 70, 7 11s are 77, 7 12s are 84, 7 13s are 91, 7 14s are 100, sorry, 98, 7 15s are 105, 7 16s are 112, 7 17s are 109. Denominator becomes 90, but sir, we have multiplied the denominator. Wouldn't the value of 7 by 5 by 7 actual value will get value? To balance that value, you need to multiply the same number in the numerator. Now, actually, what I am finding here 5 by 7, previous concept. Multiplying the numerator and denominator by the same number. Whatever we will get, that will have equal values 5 by 7. Remember the concept of equivalent fractions. Now, let me see what will this become. 5 7s are 35, 5 3 carry. 5 ones are 5 plus 3 is 8. 85 divided by 7 into 17 is 190. Now, 85 by 119 will be same as 5 by 7. Now, taking second one. Again, I am taking second one 12 by 70. Now, denominator, I have to make denominator equal to 119. How? 17 stable. 17 into 7 or 119. If you are multiplying in the denominator to balance, you have to multiply in the numerator as well. 7 2 are 14, 4 1 carry, 7 1 are 7, plus 1 8, 80. Now 17 into 7, this is 7 here, is 109. Now it is 85 by 190 and it is 84 by 190. Remember 84 by 190 will have same value as 12 by 7. And 85 by 190 will have same value as 5 by 7. So they are actually the equivalent fraction of the two given unlike fractions. Now clearly, after looking at these fractions now, the equivalent fractions that we will get for 5 by 7 and 12 by 7, their denominators are now equal. Now we will move back to the previous concept of like fraction. I have been able to convert unlike fractions into like fractions by LCM. Now among the two, clearly 85 by 190 is greater than 84 by 190. Why? Denominator is same, so among the numerator, the greater one will be the greater. But what is 85 by 190 actually equal to? It was actually 5 by 7. So 5 by 7 will be greater than 12 by 7. So we came to know the value of 5 by 7 is greater than 12 by 17, which we won't be able to calculate without making them like. So this is first example of how to compare unlike fractions. Now what we have done, we have taken two unlike fractions. We find that they both are unlike, neither numerator is same nor denominator is same. Sorry. Here they are, nor numerator is same, neither denominator is same, nor numerator is same. Then we find the LCM of 7 and 17, their denominators. We got LCM equal to 190. Now we try to make the denominator of both fractions equal to 119. How? 7, you need to see which number should be multiplied to 7 so that it will become 190. The number that you will multiply in the denominator. Same number you have to multiply in the numerator. Now, second one, 12 by 17, again same process, we get the result 85 by 190, 84 by 190. But they will be same as the given unlike fractions. Now, I clearly came to know that among the two fractions, 85 by 190 is greater than 84 by 190. But 85 by 190 is actually the equivalent fraction of 5 by 7. And in place of 85 by 190, I have put 5 by 7. Greater than 84 by 190 is equivalent fraction is actually 12 by 70. So I came to know the first fraction, that is 5 by 7 is greater than 12 by 70. Now I will take one more example and we will try to just finalize this chapter, this topic, that is comparing fractions. So let me come to one more topic, one more example here. Last example I will give. I am writing here. Compare. Now I will take three fractions. 7 by 9, comma, 8 by 11, sorry, and 2 by 5. These are the three fractions and they both are unlike. Now how to compare unlike fractions? I have already given you the method, but that was for 2 fractions. Now how to deal with the 3 fractions? I am writing the solution here. Solution I am pasting here. Since 7 by 9, comma 8 by 11, comma 2 by 5 are what? Unlike fractions. Now if they are unlike, the first thing that I have to do is to make them like by making the denominators same. How? By finding the LCM of denominators. I am writing here, therefore LCM. What do you mean by LCM? It is lowest common multiple. That means I am finding the multiples of 9, 11 and 5. Multiples. Then common multiple another. What are common between 9, 11 and 5? That is 9 on 9, 18, 27, 36, 11, 22, 33, 44, 5, 10, 15, 20. Among them, I will see which or what are common multiples. Among common multiples, I am taking the smaller. I hope you have done the same in class 6. Unlike functions. Now, therefore, LCM. Sorry. When you take LCM of what? Denominators. That's 9, 11 and 5. So I've told you the process in the previous example. Now make up a square. Write up 9, 11 and 5 on the top of the square. Now starting with the table of 2. I am seeing that none of the number comes in the table of 2. Now 3. Yeah, one of the numbers comes in the table of 2. That is 3 or 9. 11 will come as it is and 5 will come as it is. Now again, still I am finding that the 3 numbers that comes out after cancelling them by 3. One number is still divisible by 3. That is again 3 1 are 11 as it is and 5 are. Now next. It will be now neither 1 nor 11 nor 5 comes in the table. We will move to 4. No, 4 not. Why? Because 4 is not a prime number. We are doing it by prime factorization. Now 5, yes. 5 may RI, 5, 1 as it is, 11 as it is, 5, 1 or 5. Now at last it is remaining 11 and 11 is a prime number. 11, 1 R, 1 R and 1 R. Now multiplying all these prime numbers, I will get the LCM of 3 numbers. That is 3 into 5 into 11. Now 3 3 are 9 into 5 into 11. Now 9 5 are 45 into 11. Now 11 5 are 55. 5 carry 11 4 are 44 plus 5 is 49. See, it is quite large. 495 is the LCM of 9, 11 and 5. That is the first common multiple of 9, 11 and 5. That you will find is 495. 495 is the first number that comes in the table of 9, that comes in the table of 11, that comes in the table of 5. First number. 494 में कोई नहीं आ रही. Now what do we have to do next? I have to make the LCM, denominator of all these 3 fractions. 7 by 9, 8 by 11, 2 by 5. Equal to what? 495. So let me take 7 by 9. What should I multiple 7 by 9? What should I multiple 9 so that it will become equal to 495? Now how to do it? Have a look. What will you do? You will write 495 and you will cancel it by 9. Whatever the answer will come, that number we have to multiply to 9. 9 1 are 9, 9 5 are 45, 4 carry, it becomes 45, 9 5 are 45. So 9 into 55. If you multiple the fraction of denominator by 55, you have to multiply this numerator by 55 to make the things balanced. Now, 7 5 are 35, we can 7 5 are 35, 36, 37, 38, 385. At the bottom denominator, it will be 495. You can check. 9 5s are 45, 5 4 carry, 9 5s are 45 plus 4 is 49. So this number 385 or 495, it is equivalent to 7 by 9. Whatever is the value of 7 by 9, same will be the value of 385 by 490. Next, 8 by 11. Let me rub this here. Now the next number that I am taking, second one, 8 by 11. I am trying to make them like fractions. Now what should I multiply to 11? So that same number I will multiply to 8 to make the denominator equal to 495. Now for that I have told you, take 495 and divide it by 11. 11 ones are 11, 11 fours are 44. Now we are left with 5, it becomes 55, 11 fives are 55. 11 into 45, if you multiple it 45 at the denominator, you have to multiple 45 with the numerator. Now 8 fives are 40, 0 4 carry, 8 fours are 32, plus 4 is 36. Divided by 11 into 45 will be 495. You can check. 11 fives are 55, 5 4 carry, 11 fours are 44 plus 4 is 5 carry, 11 fours are 44 plus 5 is 49. So this is the equivalent fraction of what? 8 by 11. 8 by 11 का equivalent fraction. Whatever is the value of 8 by 11, same will be the value of 360 by 495. The third one is 2 by 5. So what should I multiply to 5 so that this denominator will become 495? Take a 495 here and divide it by 5. 5 1 are 5 9 are 45. 4 carry, it becomes 45. 5 9 are 45. So 5 into 99 at the denominator, then multiple 99 at the numerator. 2 9s are 18, 8 1 carry, 2 9s are 18 plus 1 19. 198 divided by 495. When you multiple 5 into 92. So this 198 by 495 is equivalent fraction of 2 by 5. Whatever is the value of 2 by 5, same will be the value of 198 by 495. Now check up the fraction that I have got from multiplying the denominators and numerators. It is 385 by 495. It is 360 by 495. It is 198 by 495. Their denominators are same, but they are like. And it is very easy to compare like fractions now. Now it's clear that among the three fractions, denominators are same, numerators will compare. The numerator of the fraction which will be greater is also going to be greater. 385, 360, 198. 385 is clearly greater than 385 by 495 is the first greater number, greater than what? Second one, 360 by 495 is greater than what? 198 by 490. Now actually, what are these fractions? 385 by 495, it was actually 7 by 9. Greater than 360 by 495, it was actually 8 by 11. Greater than, 198 by 495, it is actually 2 by 5. So this is actually the comparison of three given fractions, unlike fractions. Initially it was difficult, 7 by 9, 8 by 11, 2 by 5, it was difficult to compare which one is greater. Now at that we came to know they were already put in the sequence of their descending order. So 7 by 9 is the greatest among the three, 8 by 11 is the second greatest, and 2 by 5 is the third greatest. So this is how we compare the fractions, whether they are like or unlike. So this marks the end of our second subtopic of the first portion of the topic, that is fraction. Till now we have done introduction. Then we go through the fraction and the style. Then the third topic that we have done today is comparing fractions, whether they are like fractions or they are unlike fractions. Now the next topic that we will have as per the sequence of terminology, it will be operation of fraction. How to operate fraction, that is how to add them, how to subtract them, how to multiply them, and how to divide them. So that's very important. That is actually your syllabus. We are taking the fractions from the beginning. If you haven't ever heard about the fraction, then these lectures are meant for you. You can understand the fraction from very basics. Now we'll see you in the next lecture, lecture number 4 of the topic. Till then, take care of yourself and don't compromise on your studies. Allah.